Welcome to today's webinar. Thanks for joining us for a great discussion on choosing the right sanitization for your building. Before we get started, I'd like to take a moment to go over just a few housekeeping items. Today's webinar is being recorded. My name is Nicole Sticka, and I'm the Vice President of Energy Services with the Greater Cleveland Partnership, and I'll be moderating today's webinar. We want to make sure today's presentation is extremely valuable for you, so we ask that you submit all questions by clicking on the question button in the control panel and typing your question. We welcome questions throughout, so please do submit those during the presentation. Prioritizing decisions that improve indoor environmental quality is a necessity and an important way to demonstrate how a building is putting people first. Today, we're taking a critical look at the various technologies that you've likely heard about, such as UVC, photohydroionization, and bipolar ionization. Which one is right for your space, and which ones can significantly lessen the spread of bacteria, germs, fungi, and viruses such as COVID-19? Placement of these specific systems is extremely important to ensure their effectiveness. One of our partners at GCP, Air Force One, will be discussing the benefits of each of these systems and helping you make an informed decision for your unique needs. Now, allow me to introduce our speakers today. Brian Taylor, he's the Director of Building Automation with Air Force One and has over 25 years of building automation, programming, and implementation experience with consistently increasing responsibilities in design management and process control design. Austin Nutter is the Building Automation Account Executive with Air Force One, and Austin's industry experience includes building automation systems, energy conservation, and data communications. He custom tailors solutions through a vast array of experience with various technologies and platforms. And with that, I'm going to hand it back to Austin to get us started. So thank you for joining us, and Austin, it's all yours.
Thanks, Nicole, and thanks everybody for joining us this morning for today's webinar. Typically, this will take about a half hour. Like Nicole said, feel free to ask questions in line, and we'll answer them in line, because if you're thinking something, chances are others are thinking it. So we're happy to answer it in order. So without any further ado, let's go over what we'll be talking about today. And really, you know, the meat and potatoes is air sanitization, but there's still a lot we can do with our facilities in regards to ventilation, system filters, and routine system cleanings. So I don't want to overlook that. We're going to touch on them, but I want to throw that out there. So ventilation. Ventilation is essential to keeping people and businesses safe and healthy. It accomplishes three goals. It controls your building pressure, but more importantly, it increases indoor air quality by diluting polluted or stale indoor air. One of the things you might have heard is that the CDC, the state of Ohio, ASHRAE has requested to increase outside air. The reason for this is we know that the outside air is a natural sterilizer, so the more that we can have, the better off we are. So make sure that your outdoor air intake systems and dampers are operating properly, as well as your economizers, which proportion the relief return of outdoor air and allow for safe, healthy oxygen levels and CO2 levels.
Yeah, and Austin, I would like to add a little bit to the ventilation piece. We've talked about this a lot, and I don't think it can be overstated. Many times, if you've had any heating, cooling issues, especially like in the dead of winter or midsummer where it's hot or humid, the first thing that companies will do, and it's to try to get control of this, is either disable your economizer or minimize the amount of outdoor air going into the space. It does typically fix the issue that you're having at the moment, but it exacerbates another issue, and that's indoor air quality. So having those items, your economizer damper, which is your return, and outdoor air dampers verified for operation is extremely important.
Exactly, and as far as ventilation is concerned, I mean, it is the natural air sanitization process. So if you can open up windows and doors, it's a little easier this time of year. It's always recommended as kind of a low cost, no cost way to dilute and sterilize your air. The next important piece of this, and we've heard a lot about this, is system filters. There's been some kind of arguments on what you should do. And Air Force One is in agreement that you can install the highest rated filters for your system, but you need to know what that is. A lot of people are recommending HEPA filters or MERV 13 filters, which are great, but most HVAC systems are not designed to handle those filters. So simply switching to high efficiency filters can be very dangerous. Higher filters will reduce airflow and can cause significant damage. So it's kind of a reverse effect. You think you're actually helping with the purification of air, but in fact, you're kind of choking your system out, and it's more of a detriment than a benefit. And ASHRAE does recommend changing HVAC filters, even if they do not appear dirty, minimally at a quarterly, clip.
Right. And one of the important pieces to this is if you're an organization that has large buildup air handlers that have high static fans that have the ability to be adjusted, they may initially been designed for a MERV 8 filter, which is very typical design standard. If you're bumping the filters, that type of equipment can be adjusted to maintain airflow, so you can get those benefits. Where we see this as a major issue is on packaged equipment, especially when you start getting into smaller packaged equipment, 3 ton, 5 ton, up to 10 or 15 ton, where the fans aren't designed to go beyond the filters that were originally installed, and you start going to a higher efficiency filter, which does some good. It lowers your airflow. It can cause you heat exchanger problems during the summer or wintertime, and then cooling problems, specifically either short cycling or not enough airflow and freeze ups on your evaporator, which then reduces the life of your equipment. It's very important to make sure that you don't go beyond the capabilities of your equipment when it comes to filters.
And just in summary, and I think I saw it this week, the Governor DeWine mentioned to increase your MERV rating to MERV 13. So I caution you to, before you go out and do that, to make sure you reach out to your commercial HVAC company to make sure that your system is designed to handle that type of filters, because many are not. So we want to caution everybody listening today about that. I'll touch real briefly on this with routine system cleanings. Cleaning air ducts and coils minimizes dust and allergens. Through that minimizing of dust and allergens, you can actually reduce the spread of viruses and bacteria that likes to cling onto those. Routine cleaning of ducts, coils, and fan may also maintain equipment efficiency. In the end, it's going to extend the operating life and reduce the likelihood of catastrophic failures. We obviously need our HVAC systems right now, so anything we can do to keep those up and running is recommended. Now, Brian, do you have anything to add to this slide?
Yeah, not a whole lot of depth, other than if your equipment is clean, if your ducts are clean, your coils are clean, you'll move more airflow. Your equipment will be more efficient, so it's a lower cost to operate, and you'll get the maximum benefit of what your HVAC equipment can do when it comes to COVID.
Exactly. And I'll take a quick pause. Does any questions come in that are relevant to the last 2 or 3 slides?
I have not seen a question come in, Austin.
Okay.
Yeah, as soon as we do, I'll make sure we pause and answer it, and I'll answer it via text, and also we can discuss it.
Beautiful. So now to kind of the meat of the presentation. That's air sanitization. Providing this improves the health, productivity, and well-being of occupants. There are a multitude of products that reduce these pollutant levels, and we're going to kind of go into some detail because it is confusing. However, indoor air quality plays a significant role in reducing the effects of harmful pathogens such as bacteria, germs, fungi, virus, and what's close to everybody's mind right now, COVID-19. It also has the added benefit of reducing odors and exposure to harmful VOCs or volatile organic compounds. One thing that most people don't consider about many of these technologies, and specifically PHI or PCO, which we'll go into a little bit later, is that they are green technologies. As we mentioned in the ventilation slide, it's been recommended to increase your outside air. Well, the repercussion of that is increased utility consumption. So if we have indoor air sanitization, we can actually maintain or even reduce levels of outside air, which quickly turns into, the form of saving up to 40% from conditioning outdoor air. And I know Brian will want to talk briefly on that one.
Yeah, very specifically, when you're using whether it's a BPI, needlepoint BPI, PHI, PCO, and you're going to use it in a fashion where you reduce outside air, the one important caveat to that is, and most newer buildings will have this, but older buildings will not, is that you need to still have CO2 demand ventilation, because that's the one item that none of these technologies address, and that's CO2 levels in the space. So we'll touch on that a little bit later, but it's very important to note that you can add that when you do the air sanitization technology, but you have to have that to reduce outside air.
Thanks, Brian. So this slide, I kind of grouped it into kind of three different categories of the products we're seeing in the marketplace. And albeit they might be slightly different, there might be different means to get to what they're doing. Really, the name differentiators are strictly designed by the manufacturer, the patented name, the marketing. So we wanted to group those together so people can understand the technologies themselves. We're going to kind of go through the pros and the cons. I'll preface that with, doing this, doing nothing, any of these solutions are better than doing nothing. So I want to get that out there first, but I'll go kind of in depth on each one. So ultraviolet UVC is usually generated through an LED or a compact fluorescent light. This is something that is naturally occurring outdoors. Actually, our ozone layer completely absorbs this. So to get UVC, you have to generate that. The one drawback to UVC is that a pathogen has to cross that light ray to be disinfected. So with what we know with COVID-19, albeit it can hang in the air, it's not necessarily fully airborne. And what we're really concerned about is kind of that 6-foot bubble or the sneeze or cough distance. And UVC simply does not address that issue. And I guess I'll stop at each point and let Brian kind of fill in any gaps that I might miss. Brian, do you have anything to add to UVC specifically?
Yeah, UVC, and this is a trap we've had a lot of customers get into, and I would like to just try to clarify this for everybody on this call. It is a great point of use and surface sanitizer when installed inside of your equipment, specifically facing the cooling coil, whether it's chilled water or direct expansion. It keeps you from forming fungus and bacteria and other things because it's a wet surface. It's so cold, it's constantly building up moisture, and it does a great job of that. Beyond that, it doesn't do anything for the rest of your system. So yes, people will argue that, well, the air coming back goes to the UVC stream and then gets sanitized. The problem is to have enough ultraviolet light to sanitize air as it moves through the system at those high velocities. It would be a very large amount of electricity and an intensity that would actually self-destruct your equipment, because the ultraviolet light would destroy any caulks, anything that's not metal, and can even have some detriment to metal inside the equipment. So although it does a great job of sterilizing point of view surfaces. It cannot be in direct contact with people. It can damage your eyes within seconds, and it can't truly sanitize the air as it moves through, because the amount of UVC light that you would need is well beyond the scope of an installation and typical equipment.
Thanks, Brian. And then now is one that most people that have done any research is familiar with, is bipolar ionization. And again, there's a couple ways you can create bipolar ionization. Sometimes they call it needlepoint bipolar ionization. Sometimes they call it cold plasma. I've heard some other names, but the technology itself does the similar things. It's producing negatively and positively charged air ions that are attracted and bond to airborne pollutants, thus neutralizing them. The pros, I would say, to bipolar ionization is there's typically not a lot of ongoing maintenance other than cleaning the units themselves periodically, because none of these solutions get rid of dust. Dust is always going to be an issue. The one drawback I see with bipolar ionization alone is the short lifespan of it, but I will leave the more technical aspects to Brian. So Brian, give us your thoughts on bipolar ionization alone.
Right. I mean, bipolar definitely has a place, and it works for sanitization, albeit not quite to the same percentage that some of the other technologies do. One of the questions we get a lot is, well, needlepoint is different than other bipolar, and that is not a correct statement. Needlepoint is generated differently, and it's self-cleaning. So needlepoint definitely requires less maintenance, but it really isn't different than, if you're doing bipolar ionization, whether it's through needlepoint, whether it's through cold plasma, whether it's through some other form, as Austin stated, you're just creating positive and negative ions, which do what they say, and also touched on the life is very short-lived, because they react with things that are in the air. They react with other positive and negative things, whether they are truly a VOC or something bad or not. So they definitely clean the air as it goes through the system. Once it's into the space, typically most of those ions are depleted, and you don't have a continuous ion level in the space. That's not necessarily always the case. It depends on how many you're building, but when we've done some testing, that's what we have found.
Thanks, Brian. And then the last kind of grouping that I put together is what commonly industry standards called photocatalytic oxidation, or PCO, and then the more kind of patented technology that uses the same kind of logic would be photohydroionization, or PHI, or sometimes it's referred to as dry hydrogen peroxide, or DHP. And this technology kind of combines everything that we've talked to up to this point. It does use UV light, not as the main source of disinfection, but for its reaction to a catalyst and moisture in the air. And this creates advanced hydroperoxides, superoxide ions, and hydroxide ions. In simple form, and I think that's why it's been coined dry hydrogen peroxide, is it's going through the chemical process of creating H2O2 without having to add the chemical itself through a natural occurring phenomenon. And we'll kind of jump a little bit more into that technology. That's it at a very high level. Brian, you got anything you would like to add?
Yeah, I would like to touch on this one.
Okay.
Where the big difference is the whether it's PCO, whatever you want to call it, any of the H2O2 generators also use bipolar ionization. So you're getting the positive and negative oxide ions and hydroxide ions, as well as the hydrogen peroxide, the pure H2O2, in a prescribed dose, if you will, into the space. The cool thing is even though the ions get used up very quickly, the H2O2 can go into the space and exist in the space until it reacts with something that it oxidizes and then reverts back to oxygen. It definitely has a longer space life. And as we go further into this conversation, you'll see that it actually has the ability to sanitize the air in the moment with a sneeze and as people are interacting within a space.
Thanks, Brian. And yeah, I think actually the next slide kind of shows just kind of a graphic of how this works. And it's very similar. I mean, when it comes to UVC, that's usually installed on the coils, which is going to be a heating or cooling coil in your HVAC system. Typically, best practice for BPI or bipolar ionization or PHI photohydroionization is to install it on the discharge side of your HVAC equipment. So we install it in the ductwork, and it recreates the outdoor air indoors, eliminating 99% of airborne pathogens while disinfecting the airstream and hard surfaces. And then you kind of get the full cyclical effect where it gets sucked back into the system and it's going to sterilize your coils and your filters. That's kind of just a high level graphic of how it works. But I think it's interesting nonetheless. And Brian, I know you want to talk, but I figured if I go to the next slide, we kind of start clarifying some of this information, and then we can go from there, kind of filling in the gaps. So, you know, specifically to PHI or photohydroionization, the data suggests and the data proves that it reduces viruses, bacteria, odors, air pollutants, and VOCs. And like we mentioned in the first slide, it creates all these various hydroperoxides and super ions and what have you. But the simple way to think of it is these are friendly oxidizers. What they do is they react with a pollutant or pathogen in the air, and then they revert back to oxygen. And that's why you can actually increase your oxygen levels with PHI installed. PHI can reduce microorganisms by 99.9% in the air and on all hard surfaces, and we will have some graphics that show how that works.
Yeah,
Brian,
I want to touch on one point. One of the big, whether it's PCO, PHI, or one of those negatives that people bring up are the ozonide ions, which is ozone or O3. That only gets generated if you're using a standard fluorescent form or compact fluorescent form of UV generation. That's actually part of the UV process. And if you're using most of the newer technologies that do this, use LEDs, which do not produce ozonide ions or ozone. And it's very important to select one that doesn't produce ozone. Although ozone is a great oxidizer and it actually helps the sanitization process, it can also be hard on people who have respiratory illnesses and so forth. So it's very important to make sure that you are using one that's LED based and you don't have that, then that's a non-factor.
That's a good point. And ozone was used for sanitization for quite some time. The problem was that nobody was monitoring and limiting the exposure. And that's one of the kind of objections we've heard with PHI is that we are generating ozone, which would be the case for the solutions that use compact fluorescent bulbs. But typically the ones that we install, end quote, are LED based and they generate zero ozone. So that's definitely a good point, Brian.
Right.
Was there a question?
No questions yet.
Okay, perfect. So this is kind of in regards to some of the testing data. And there's testing results for multiple strands of viruses, bacteria, molds. But the one that, you know, obviously most people are concerned about right now is SARS-CoV-2. In this particular test, what they did is they created a chamber and nebulized the virus continuously. And Brian would like to elaborate on this, but essentially there was zero hydroperoxides in the air. You install PHI, you turn the unit on, there is a ramp up period to saturate the chamber, the space into a normal level. But within 1 to 2 hours, it has an inactivation rate of 99.9%, and that is in real time. So as that unit continues to run, it should maintain those levels going through the future. Now, one question we get asked is, well, what does that mean? Do I have to run it continuously? No, typically we have those interlocked with your HVAC system's fans, and we just recommend that you give it, the system being on an hour or two prior to occupancy, so the saturation levels of H2O2 can reach that kind of threshold to where it inactivates the virus or pathogens by 99.9%. And Brian, I know you have things to add about that.
Yeah, there's a couple things, and I know we're going to probably talk about this later, but I know people are probably questioning this. H2O2 is actually produced naturally outdoors through the sun, which is, of course, a huge UV source, naturally occurring metals, and of course, H2O2 or water or moisture that's in the air. So the whole idea is recreating that natural process indoors that happens outdoors and keeping it at a level that's equal to the outdoors. So it's extreme, because the first thing people ask is, well, is that safe? Yes, it's 100% safe. There's really no issues. Hydrogen peroxide has been in the medical industry for a very long time, used in many, many ways, and it's naturally metabolized by humans, actually all mammals, because it's a natural part of our outdoor environment. So with that said, the reason this test has a ramp up time is because, as Austin pointed out, there was a nebulized CoV-2 in the chamber, and then they turned the PHI on, and then because of the volume and the saturation level, it took between 1 and 2 hours to get to a zero, but the 99.9%. Once you're there, it continuously stays. Now, this doesn't mean that you need to keep your equipment on overnight when people aren't there. It just means that your equipment needs to run when people are there, moving air. So you can still shut it off at night, because as long as there's not people there, you're not reintroducing, or you don't have the possibility of reintroducing the SARS. Run it when people are there, off at night, so it doesn't affect your energy bills. And this is the only third-party verification of any of these technologies that I'm aware of, specifically to SARS-CoV-2, which is huge. It really shows the power of the H2O2.
Thanks, Brian. And then, as we mentioned, I mean, there's other things that come into play with air sanitization, right? Obviously, right now everybody's focused on viruses, but mold, yeast, bacteria, allergens, those are not going away. Those are things that persist in buildings and even in your homes, no matter what's taking place in the world. So this test looked at mold, yeast, and bacteria specifically, and albeit it took a little bit longer of a ramp up, it did experience a 97% plus inactivation within that 48-hour period. So we kind of mentioned this whole thought of nebulizing, and that's just a fancy word for simulating a sneeze. When we sneeze or cough, you'd be surprised at the velocity that those respiratory droplets actually come out, and that's what they're trying to simulate. What we know is to stay away, 6 feet from one another, social distance, wear a mask. What this test looked at, and this was specifically done as a proof of concept for the TSA, was what was the impact immediately from a sneeze. And what they found are their oxidizers are already in the air, ready to kill microbes at the source, to the tune of 99%. Meaning, if you sneeze, there's once the room or the space or the building has been, at the optimal saturation level, there's going to be a 99% reduction 3 feet away without a mask on. So, Brian, do you have anything to add to that slide?
No, I think that the graphic speaks for itself.
Yeah,
the
exactly.
test speaks for itself. And the other thing that I think is really important here that I think we could provide to GCP and they could distribute is there's white papers on all these tests that give all the finite details. If anybody's interested in that, we'll try to find a way to get that to them, because at the end of the day, everybody on this call has probably had 1 million people come to them. They're trying to say which technology is better, why it's better because they carry it, which one's cheaper, yada, yada, yada. There's a lot of graphics, there's a lot of marketing material, but at the end of the day, you need to make sure that it works and actually delivers on what it says it does. So we'll provide as much as we can, and hopefully that gets distributed, because it's important to understand the details on this.
Thanks, Brian. And we kind of touched on this earlier. This kind of comes full circle, and this is one of our last slides, is really the goal with any of these technologies and air sanitization is recreating the outdoor air indoors. What's outdoors naturally occurring? The sun is a large UV source. Our ozone layer has naturally occurring metals that react together with moisture in the air, creating hydroperoxides. There's a reason why this virus has a tough time living outdoors. There's a reason why, when you walk outside, it just feels fresh. I mean, it's a natural sterilizer when you walk outdoors. And when we're all cooped up, wherever you're at in Ohio in the middle of winter, and you're all, in confined spaces, not getting your vitamin D, is when we see these flu the flu season, when we see increased, COVID tests, positives, and really the goal here is to increase those outdoor hydroperoxides indoors, because they will build up if left on their own devices. So, Brian, do you have anything to add to that slide?
No, I think you did a good job, and it ties on to what we talked about earlier on how this is not a chemical. It is not something that's beyond a naturally occurring process, which makes it extremely.
Yeah, and I think that's another good point, and it made me think of it. You had mentioned that people ask if it's safe, right? And we talk about the outside air, and I believe that if you were to measure the outside air at any given point, there would be like 0.05 parts per million of H2O2. What we're producing indoors is somewhere between, I think, 0.01 and 0.02 parts per million, which is about half of what we get outdoors, but still more effective than not having any. Now, I have seen some technologies that I've drilled into the white papers, and they're generating such a finite amount of hydrogen peroxides that it leads me to question if it's really going to be effective. So just keep that in mind. We know it's confusing. There's a lot of various technologies out there. We've installed them all for different reasons. So if you'd like to wade through, like Brian said, a lot of that marketing material, there's a lot of graphs of what things have and what things don't, and pros and cons. We'd be happy to assist you with any of that information. And with that, it leads us to questions. I like to keep these presentations about 30 minutes. It looks like we're at about 34 to give ample time to answer any questions. Not sure if any came up. If you think of any right now, and now would be the time to ask us. We're happy to answer them. If you're thinking of those questions, chances are somebody else is thinking about them.
Yeah, I have no questions.
Oh, go ahead, Brian.
No, I was just saying, I don't have any questions on the board that I see.
Okay. The one question that people may be thinking is, with the various technologies that you have outlined today, for many, they may not have budgeted for anything like this. And while they want to bring people back safely into their buildings, what's the appropriate next step if they haven't budgeted for something of this nature? And if you can speak to perhaps the range of cost, from low cost to the most capital intensive, so that from a long-term planning perspective, they can figure out what is most appropriate for their space.
Great question, Nicole. Brian, do you want to start out with that one, and then I can fill in any gaps?
Yeah. So
Common questions that come up.
Yeah, so basically, and this is a budget cost, but it's fairly accurate. When you're talking smaller equipment, 3 to basically 15 ton, which covers a wide range of equipment that's out there, especially in the light commercial space, or when you only have 1 or 2 units. It's anywhere from $900 to basically $1,500. And that really depends on the installation of the equipment, right? If we have to make a roof penetration, it's going to be a little more cost. If it can be installed right in the unit, of course, that's the lower cost. Or if it's, smaller equipment inside the space and everything's right there, that's how you get to the lower cost. Now that's up to approximately 16 tons. As you go beyond that, it scales basically the same. You could double the cost for every 15 to 16 tons of cooling is what we're finding. And Austin, please fill that in if you think that that's inaccurate.
No, I think that's pretty accurate from what I've seen. Now, the one question, Nicole, you also brought up is, we would like to add it, but we don't have the budget for it. And obviously that's a concern. Please be aware that Air Force One does have partners and does actually provide some assistance for kind of self-funding some of the smaller projects. If your project's a little bit larger, you can always look at like maybe an Energy Made Easy program, which is a no out-of-pocket. It rolls into your utility bills. Oftentimes we can reduce your utility bills, and with the return on investment in the technology, sometimes it's a break even. And then for your larger facilities where you have some upgrades that need to be done, whether it's lighting, controls, air sanitization, even roofing, and some exterior needs, then you might want to look at something like a PACE program, which we can also work with you and provide that kind of expertise. So really, there's a solution for every organization. We've installed these in owners' houses, in daycares, in schools, government buildings, all the way up to, into large museums and science centers. So there's a wide range. And one thing I didn't touch on, but now that I'm talking about, there's kind of a solution that fits all kind of budgets, sizes, organizations, is there are self-contained units as well. So some people may not want to have a permanent solution. So most of these solutions do have a standalone or an autonomous type portable unit as well. So throw that out there.
Right. The other thing on the funding, Austin, that I wanted to slip in there is all of these products, and that includes whether all the different names, but all the different technologies are covered under the CARES money. So if you're looking to try to get CARES money, or you have CARES money, you can fund these installations using that money, and it qualifies.
That's a great point. And we have definitely guided a lot of businesses on how best to use those CARE dollars, even working with municipalities that are expecting larger sums of cash from the federal government to determine how best to utilize those dollars, not just for the immediate future, but for the long-term health and well-being of those buildings. We did just get a question in, and that is there a long wait time to get a unit installed at this time? Are there any supply shortages? That's a great question.
That is a great question because, and I'll start out, Brian, and you can finish this one off. At the onset of this, nobody saw the pandemic coming, and there was shortages for all three of those kind of technologies that we've discussed. Since then, most companies have ramped up, and we are seeing very little lead time on the product itself. Brian, do you have anything to add to that?
Yeah, I was going to answer this over the text too, so that way we at least have documented. But no, there's probably no. We definitely prefer the PC PHI solution. We've installed the global, the GPS solution, the needlepoint bipolar ionization as well. Between either of those, we've had really no issues on delivery. Like Austin said, early on, everybody was not caught. You know, they weren't prepared. They were kind of caught offhand. But over the last 6 to 8 months, we can, if we get an order, and I'm going to assume that your provider can do the same thing, we can generally install it within a week or two, just fitting it into the schedule. We can have product within same day or a day most of the time.
Oh, that's great. I don't see any other questions at this time. But, you know, there's a lot of terminology that has been shared today, but hopefully this webinar did help everyone better understand the various air sanitization technologies, that you're more informed about which one may be right for your building. As Brian and Austin alluded to, it's obviously best to work with your contractor and determine what's right for your building based upon your needs and what the current equipment is in place. But if you still do have questions, we encourage you to reach out to the Greater Cleveland Partnership Energy Team, Air Force One, and we'll certainly guide you to choosing the right technology. Before we close today, I also want to mention one of our next webinars that's coming up next week, April 14th, and that's on PACE financing and providing a Northeast Ohio market update. One of Air Force One's colleagues will actually be joining us talking about how PACE financing can be used for more capital intensive equipment and using this alternative financing method as a great way to pay for projects that have a longer term payback, maybe more expensive, but it provides you a great no front out of pocket cost to the project. So you can look for that webinar on the Greater Cleveland Partnership website, gcpartnership.com/events. And with that, I'd like to thank today's speakers, Brian and Austin. Again, thank you all for joining us. I hope you found this valuable and a good use of your time. With that, be well, stay safe, and have a great day.
Thank you. Thanks, everyone.
Thanks, everybody.
Thank you.